The development of a structural analytical model is an essential step in a structural engineer's BIM process. This model is often used in collaborative workflows across engineering teams. For many years, Autodesk Revit has offered features for structural analytical modeling. However, structural engineers are looking for more flexibility and control over their analytical modeling process, particularly for complex structures, as this will enable fully bidirectional workflows between Revit and analysis software. To that end, Revit 2023 introduces a completely new approach to structural analytical modeling. As before, you can leverage existing physical geometry in 2D and 3D views as context for the analytical model. The analytical model remains associated to the physical geometry but is now independent, providing you with the benefits of speed and accuracy in model creation while protecting the analytical model from unexpected changes. When modeling analytical elements, you can now assign their structural role, type and profile shape, define their cross-section rotation, and specify how these elements should be analyzed. To keep track of the relationships between physical and analytical model elements, you can easily associate them to each other. Once it's done, associated elements are highlighted upon selection. Revit 2023 also introduces structural analytical model automation. This tool enables you to generate a structural analytical model automatically from selected physical geometry, and it offers many options for customization. This tool also ensures that the automatically created model remains consistent and connected, eliminating the need for tedious corrections. You can design a first, second, and third priority element hierarchy. This is useful, for example, when prioritizing column locations over beam locations. First priority elements are the master elements, meaning that second and third priority elements will snap to them. Likewise, third priority elements will snap to first and second priority elements. You may specify a tolerance for the distance between analytical elements. You can decide whether or not the newly created analytical elements should be associated with their physical counterparts. You can also choose to have analytical elements inherit their properties from associated physical elements such as material, section type, and cross-section rotation. You can specify whether analytical openings should be created for selected floors and walls. Finally, once the analytical model has been generated, it can be updated easily based on physical model changes. As the analytical model is now completely autonomous, you can choose to initiate structural analysis workflows from Revit without any physical context. For example, when starting a project from scratch, you can focus exclusively on analytical modeling, just like you would in traditional analysis software. In Revit, analytical elements are fully parametric and are associated with grids and levels, enabling you to control element positioning using these datums. This new approach to structural analytical modeling offers many benefits to structural engineers. They can more easily create representations for any type of structure: buildings, bridges, frames, pavilions, stairs, and more. They can create consistent analytical models that align with the preferred engineering approach. They can enable structural analysis jobs from Revit models. They can even create multiple analytical models for a single physical representation and consider various analysis approaches simultaneously. In short, engineers will benefit from improved efficiency, accuracy, and flexibility in developing analytical models for their structures with Revit 2023.